Hello everyone, welcome to Codecrafters Lab. So now we are solving the check if the array is sorted problem, which is the last problem in the basic arrays list. So let's try to understand this. So here we are given an array of size n, and the task is to check if the given array is sorted in ascending, increasing or non-decreasing order. Okay, and if the array is sorted, then we have to return true, else we have to return false. Okay, so here in the example we can see n equal to 5. So array is 1 2 3 4 5. We know it is sorted, right? So we can say it's true. Then n equal to 5 5 4 3 2 1. Is it sorted? Yes, it is sorted, right? It is sorted, but it's in the descending order, right? We have to sort it in the ascending order only. So we can say false. Yes, it's true. Let's try to understand this. So let's say we are given n equal to 5 and array is something 1 2 3 4 5. So can we say, like, we have to check whether I1 is less than all these numbers after this? Yes, we can say that. Then we have to check for every number, right? So if I equal to 0 1 2 3 4, so we have to check for every number whether the numbers after it are greater or not. So like that is how we can say whether the array is sorted or not. That is something that comes to my mind at first. So we can write the first for loop like this, right? I equal to 0 maybe, and I is less than n I plus plus. So I will traverse to all the elements, right? When I come to this element, what I need to do, I need to check whether this one is less than all these elements. How we can do that? We have to write one more for loop. We don't have to check the zeroth index with itself, right? We have to check the numbers after it. After 1 we have to check with 2 3 4 5, right? When we come to 2 we have to check with 3 4 5, right? When we come to 3 we have to check with 4 5. When we come to 4 we have to check with only 5, and after 5 we have to check with the numbers following. We don't have to check the previous number because we have already calculated them, right? So j equal to I plus 1. Can we say that? Yes. And j is less than n and j plus plus. And inside that what we will write, if a of i, right? A of I, when we will return false, it's not a ascending order. When this is greater than this, right? Maybe if this is my a of I, right, and this is my a of j. If a of I is greater than a of j, right, a of j, then we will return false here only. And when we are returning false, that means the loop will break, right? And even if they, let's say it is not 3, maybe it is a maybe it is, let's say at 2, maybe it is, let's say a of I is greater than a of j, maybe it is 4. Let's say one more example, 1 4 3 2. Okay, at this point this is my a of I, and I am checking with these two numbers after this, right? And now this is my a of j. Now a of I is greater than a of j, right? Greater than equal to a of j, right? In this case what we'll do, that means it is not a ascending order, and we will return false here itself, right? And at the end what we'll write, return true. That means once everything is calculated, that means it is a ascending list, right? Return true, we can say that, right? Let's try to write this code here. For int I equal to 0, I is less than n, I plus plus. This is for the picking the number, and then one more for loop to traverse through the following numbers. Int j equal to I plus 1, j is less than n, j plus plus. right? Inside that, what we'll do, if a of I is greater than a of j, anytime we came across this condition, this is means it is not a ascending order list, sorted list. Return false, right? Return false. Okay, this if is ending here, this for loop and this for loop, and at the end return true. Let's try to run this. Sorry, it is array, right? So we have to make array of I and array of j. Okay, this is accepted, but in this case we can see the time complexity. This loop is running from 0 to n, and this is running from 0 to n minus 1. It is nothing but O of n square, right? And space complexity is O of 1. So can we reduce this O of n square? Can we reduce it? Yes, we can definitely reduce it. So we'll try to see that approach in the next lecture. Thank you for watching.